Hello and welcome to today's lecture on Quicksort. In this lecture, we are going to see how Quicksort works and what is the partitioning algorithm and what is its significance in the working of Quicksort. So basically, Quicksort is also a divide and conquer based algorithm. In this, we choose a pivot element. So in choosing the pivot element, after running the partitioning algorithm, the pivot element reaches its correct position in the array, such that all the elements to the left of the pivot element are either smaller than or equal to it, and all the elements to the right of pivot are greater than it. So let's see the procedure how to run this quicksort algorithm. So first you will take an array. Suppose you have an array A from P to R. Okay, the indexing are from 0 to n minus 1. Now the divide problem is, in this you have to choose any element which will work as a pivot element. Okay, and then you'll start rearranging all the elements such that the elements to the left of the pivot are less than or equal to it, and elements to the right of the pivot are greater than or equal to it. This is called partitioning process. Now let's try to write the algorithm for this partitioning process. Now let's demonstrate the partition algorithm by taking an example. Suppose we have an array A. The array consists of numbers like 12, 39, 42, 33 and say 15. Okay. Now this is your P, this is your R. Okay. The indexes are 1, 2, 3, 4 and 5. Now according to the algorithm, X will get the value A of R, that is A of 5, which is 15. I will get the value P minus 1, that is 1 minus 1, which is 0. Then you will run the loop for J is equal to P, which is 1, to R minus 1, that is 5 minus 1, which is 4. Now start comparing. If A of 1, that is if 12 is less than equal to 15, that is correct. So we'll increment the value of I. I now becomes 1, and you will exchange A of 1 with A of J, that is with A of 1 only. So 12 remains at its position. Now if A of 2, that is 39, is less than equal to 15, that is incorrect. So we'll move. Now we will check if 42 is less than equal to 15, that is also incorrect. Then if 33 is less than equal to 15, that is also incorrect. Now the value of J becomes 5. Will come out of the loop. We will exchange A of I plus 1, that is A of 2 with A of R, that is A of 5. Okay. Now we are going to exchange this. So at this position 15 will come and 39 will go at this position. Okay. So the new array becomes 12, 15, 42, 33 and 39. Now this was your pivot element. Now you can see all the elements to the left of it are less than or equal to it. Here in this case it is less than, and all the elements to the right of it, that is 42, 33 and 39, they are greater than 15. They need not be sorted at this position, but when you will call this quicksort recursively, then at the end they will be sorted. Now let's try to write the algorithm for quicksort. Now here we are calling quicksort on the array A with the starting index as P and the last index as R. Okay. Then you are partitioning this array and you're storing that in the variable Q. So you know that if you take this element as the pivot, it will reach its correct position. So the array will be divided into two parts. Okay. The left part, all the elements will be either less than or equal to the pivot, and all the elements to the right will be greater than it. Then on this left part and on this right part, you will call quicksort recursively. So you are calling quicksort on the array A from starting till the pivot. Okay. And you're calling quicksort on the array A from the next element of the pivot to the end, that is on the right part. Okay. And this is your left part. So this is how you design a quicksort algorithm. Most of the work in quicksort is done by this partition. Okay. So as we know, we are doing the division work in this partition only. By selection of pivot and taking it to its correct position, we are dividing the array in two parts such that one part is less than pivot and other part is greater than pivot. So the division part happens here. Now let's see what are the conquer part and what are the combined part in a quicksort algorithm. So as we know that in the divide part, we are selecting the pivot and taking it to its correct position. Now in the conquer part, we are recursively sorting the subarrays from the starting till the pivot, that is the left hand part of the array, and from the next element of the pivot to the end of the pivot, that is till the right part. Okay, till the end of the array. And in the combine step, nothing really happens because at each iteration, one element reaches to its correct position. So by the end of all the iterations, all the elements will be at their correct position. So in quicksort, nothing happens in combine. This is the difference between quicksort and merge sort. All the work in the merge sort happens at the combine step, and in the division step there does not happen anything. You just simply add p plus q and divide it by 2 and take the floor of it, and you do the partition, and most of the work is done in the merge part. But in quicksort, the most of the work is done while dividing the array. Okay, and in the combine part, nothing is done. Okay, in the next lecture we will see how to analyze the quicksort and what are its best case, worst case and average case complexities. Till then, thank you.